Okay, in this video, we're going to be talking about solving absolute value inequalities. I did another video before about solving absolute value equations. These are a little bit similar, but just a little bit of nuances with them. So you'll see the similarities if you watch the previous video, but I'll explain some nuances with these. Okay? All right, here we go. Okay, so whoops, looks like I forgot the absolute value. Those are those two bars. Okay, so for this equation, if you saw the previous video, you'll notice that the first step is isolating the absolute value portion of your question on the left-hand side or right-hand side of the inequality in this situation, so meaning you want it by itself. You want nothing adding it or subtracting it or multiplying it. So in this situation, we're good already. So once you already have it isolated, you can you can drop the bars and then split your inequality into two parts, a positive part and a negative part. But with the negative part, the inequality flips. So we notice that we went from less than or equal to, and then we went to greater than or equal to. So that's just the big nuance that you have to watch out for with absolute value inequalities. So now we just solve as usual. So subtract 2 on both sides. That gives us x is less than or equal to 2. And then on this side, you subtract 2 on both sides. That gives us x is greater than or equal to -6. So on a number line, you could plot these. You have -6 here, you have 2, and you're seeing that the solution is slated to be greater than -6. So theoretically, you could test points before and after -6 to the left and to the right to see if this statement is true. And the same goes for less than or equal to 2. You can test points before or after. We can go over that on a different video, but I just wanted to give you like the basic understanding of just solving absolute value inequalities. So that's one example here. Let's dive into another. So in this, we have a little bit more involved of an absolute value inequality. So like I said before, you want to make sure that you isolate the absolute value by itself. So let's get rid of this +1. So now on my left-hand side, I'm left with 2 absolute value 3x minus 1 is less than or equal to 8. And then from here, let's divide both sides by 2. So that gives me just the absolute value of 3x minus 1 is less than or equal to 4. Keep in mind, had we divided or multiplied across an inequality by a negative number, so if this were -2, this sign would flip. Just something to keep in mind. So this would have been greater than or equal to. But as it stands, it stays the same because we did not multiply or divide across the inequality by a negative number. Okay, so we can keep going. Now that we've isolated for just the absolute value, we can split into a positive and negative. So we have 3x minus 1 is less than or equal to 4, and 3x minus 1 is greater than or equal to -4. I flipped it right here. So now let's solve, add 1 both sides. That gives us 3x is less than or equal to 5. Divide both sides by 3. You get x is less than or equal to 5/3. On this side, you have +1, +1. This cancels out, leaving you with 3x is greater than or equal to -3. Divide by 3 to isolate for x, x is greater than or equal to negative 1. So that would be our final answer for this guy right here. And third question, so you would think that, or maybe you have an inclination to multiply both sides by 8, right? To get rid of the denominator and then do your positive and negative workout for your absolute value equation or inequality in this situation. But the 8 that's in the denominator here is also inside the bounds of your absolute value, so you don't have to do that. So from here, let's just separate our two sides. So we have 8 minus 3x over 8. We can drop the bar, greater than or equal to 10. And we have 8 minus 3x over 8 is less than or equal to negative 10. Let's do this side first. So let's get rid of the 8 in my denominator by multiplying by 8 on both sides. Leave me with 8 minus 3x is greater than or equal to 80. Subtract 8, subtract 8. Negative 3x is greater than or equal to, that's going to give us 72. And then let's divide both sides by negative 3. And that gives us x is, what is that? 3 and a 7 is 2, remainder 1, so 24. I think that sounds about right. Negative 24. And remember what I said, if you multiply or divide across an inequality by a negative number, you have to flip the sign. So this sign now goes like this. It goes from a greater than or equal to a less than or equal to. Okay, let's see the other side. Multiply both sides by 8. Cancels out. 8 minus 3x is less than or equal to negative 80. Subtract 8, subtract 8. Cancels out. This becomes, what's that, negative 88. Divide by negative 3, divide by negative 3. Kind of rushing here before my iPad dies. It's on 1%. And then the sign flips since you divided by a negative number. You get rid of your two negatives because a negative divided by a negative is a positive, and you're left with 88 over 3. So these would be your two solutions for your inequality. Again, you can test points before and after just to verify that the solution is true to what you originally began with, but this is just in a nutshell how you'd go about solving the equation at first. All right, well, let me know if you have any questions in the comments. You can drop them, or if I made a mistake, please let me know so I can correct myself for future videos. Appreciate it. Thanks again. Talk soon.